So now we've got probability, and we're almost there. What happens, of course, as time evolves, we get more and more and more information. And as we get more information, then our probabilities should change if we're getting relevant information that will force our probabilities to change. Okay? So how do we incorporate that into probability? And that's the topic I'll be talking about next, namely conditional probability. So here's the notation. Suppose, like before, we're interested in the probability of the event B. But suppose now I also want to bring into consideration the fact that the event A has happened. So what is the probability of B given that the event A has happened? That is what conditional probability is about. So how do we start off with the probability of B. How do we modify this knowing that A has happened? So if A is sort of simpatico to B, then P of B given A should be bigger than P of B. If on the other hand it's antithetical or antipatico, then it should go the other way. So the question is, how is the probability of B given A changed to incorporate this information that we have now detected that A has happened? So, for example, let's go back to our US life table and ask this question. So, let's say that the event B is that a person in the US will live to be 70, and the event A person is alive at age 65. Then the event B given A is that a 65-year-old person will be alive at 70. Okay? That's different than B. B can be evaluated at birth or any time later. But of course, we're only interested in if we know that B is alive. So the question is, if you're selling insurance, would you charge the same thing for a baby to reach age 70 as you would a 65-year-old to reach age 70? Already you can think about it, because for the baby, that baby has to live another 70 years, whereas the 65-year-old only has to live another 5 years. So you think they can't be the same, and they're not the same. They're not the same. But how can we get one from the other? So here is what we saw earlier when we looked at the life table for 2007 in the USA. And this is how this cohort of 100,000 people born in 2007, how they're going to die as the years progress. All right? And there's that, remember we said there was a big number there, and then it sort of goes down here. Most of us will die probably in our 80s and so on. And George Burns said very few are going to die here, and that's right, because there's very few left. So anyway, so this is what we call the density function. Whereas we also had from the life table the hazard function. And the hazard function, remember the definition of the hazard function. The hazard function was, given that you are alive at a particular age, what is the probability that you'll die within the next year? Now, we still have that problem there, but now we don't have this thing coming back down, because the probability of dying within the next year of life when we're up here is very, very high. So those are two different situations. Probability of dying at any particular age, and there it is, after you are born, and this one, the hazard function, brings in more information. It's the probability of dying in the next year, given that you are alive at the beginning of that year. So there they are, two different pictures. This is conditional probability. This one is a conditional probability. Conditional on being alive at a particular age. What is the probability I'll die in the next year? Okay? Two different concepts. Highly related, of course, but different. And here is the formula how you get from one to the other. So the probability of B, given that A has happened, is the probability that both happen divided by the probability of A. And I'm assuming that we're not dividing by 0. So I'm assuming that the event A can happen. So there it is. There's the formula. So going back to our example, if B was that a person will be alive at 70, A that the person will be alive at 65, and B given A is that a 65-year-old person will be alive at 70, then the event A and B, you see we have to introduce a new event, A and B, is that a person will reach 65 and a person will reach 70. That's A and B. Well, clearly, because if a person reaches 70, they will already have reached 65. This reduces to a person reaches 70. So if we go to our life table, there's our life table. Let me remind you of what we saw in our 2007 life table. We can see of the 100,000, remember 100,000 started off, and here we go, 83,587 reached age 65, and 77,085 reached age 70. So if we bring that all together, there's the 83,587, there's the 77,000 of these 10,000. Then the probability of A and B. Now remember, A and B is reach 65 and reach 70, which is the same as reaching 70, is these guys. So that's 0.77. So 77% of all babies born in this construct, this fictional cohort that we set up in 2007, 77% of those people will reach age 70. Now the question is, this one though, we would like now to know, of those who reach 65, what proportion, what's the probability that they will reach 70? Well, what's the probability of reaching 65? Well, there it is. It's the 83,587 of the 100,000 reach age 65. What's the probability of A and B? There it is. So now we've got all the ingredients, and we can use the formula for the conditional probability, take the ratio of those two, and there it is, 0.92. So 92%, or the probability is 0.92, that a 65-year-old will reach age 70. Okay? So it's much higher than at birth, as we figured. You expect it much easier to live another 5 years than it is to live 70 years. And here it is. That's how much bigger the probability becomes. In the Venn diagram, this is a special Venn diagram because A is the event you reach 65, and there was 83,000. The event B was that you reach 70, and so this is a sub-event, or it's a subset in the Venn diagram. B is completely engulfed in A. So B and A and B are one and the same in this one particular case. So if we did it directly, we would say, all right, now we know that A has happened, so forget about all these things out here. We don't care about that because we know that A has happened. So let's just focus in on A. So A becomes our S. And of those 83,587, how many reached 70? And the answer is 77,085. Take that ratio is 0.92. So we get the same thing in this particular case when we can actually calculate this directly. We get the same answer whether we use the formula or whether we calculated it directly. So that is conditional probability.